Most moons are dead, frozen, silent, geologically finished. But orbiting Jupiter, there is one moon that refuses to behave like a moon at all. Its name is Ganymede. It is larger than the planet Mercury. It carries its own magnetic field, the only moon in the solar system that does. And buried beneath its frozen shell, it may hide an ocean holding more water than every sea on Earth combined. And now, scientists are suggesting something stranger still. That deep inside Ganymede, something is still happening. Its core may not be cooling. It may still be forming, not millions of years ago. Today, billions of years after the birth of the solar system. Ganymede is the largest moon in the solar system. It orbits Jupiter alongside Europa, Io, and Callisto, the four giant moons first spotted by Galileo Galilei in 1610. But Ganymede stands apart from the rest. It is roughly 5,268 kilometers wide, about 3,273 miles, larger than the planet Mercury. If it orbited the Sun directly instead of Jupiter, we would almost certainly call it a planet. Its surface is a frozen landscape of cracked ice, ancient impact scars, and vast dark plains shaped over billions of years. Surface temperatures hover near -160 degrees Celsius, around -260 Fahrenheit. Cold enough that water ice behaves more like solid rock. But beneath that shell, scientists believe Ganymede may hide a vast underground ocean, possibly more water than all of Earth's oceans combined. And hidden even deeper lies the real mystery. Because the strangest thing about Ganymede isn't on its surface. It's invisible. In the 1990s, NASA's Galileo spacecraft made multiple close flybys of Ganymede. And during those passes, it detected something nobody expected: a magnetic field. Not Jupiter's, Ganymede's own. To this day, Ganymede remains the only moon in the solar system known to generate a magnetic field of its own. Magnetic fields are not decoration. They are evidence that something is moving, actively, deep inside a world. On Earth, our magnetic field is born from movement inside the liquid outer core, swirling molten iron, creating what scientists call a dynamo. But moons are supposed to cool quickly. On cosmic timescales, they're supposed to go quiet. So why is Ganymede still humming? For decades, the assumed answer was simple: that Ganymede formed a hot metallic core long ago and has been slowly cooling ever since. But the math never quite worked. So researchers began to ask a different question. What if Ganymede's core never finished forming in the first place? In this newer view, Ganymede may have begun its life as a relatively cool mixture: rock, ice, and metal blended together. Instead of rapidly separating into neat layers early in its history, it may have warmed up gradually over billions of years. And today, iron may still be sinking, slowly, toward the center of the moon. That idea pointed scientists towards something unusual: a warming-driven dynamo. Magnetic fields, in the traditional picture, come from cooling. But this newer theory suggests Ganymede may be doing the opposite. As the moon slowly heats up internally, liquid iron continues separating from surrounding rock and drifting downward. That motion alone could generate a magnetic field, not a dying core, a forming one. And it challenges one of the oldest assumptions in planetary science, that worlds become quieter as they age. Magnetic fields are shields. Earth's field deflects much of the dangerous radiation streaming from the sun. Without it, our atmosphere would slowly be stripped into space. So, understanding how dynamos start, last, and fail is central to understanding which worlds in the universe could ever remain stable enough for life. And Ganymede combines three things rarely found together: a deep ocean, internal heat, and a magnetic field. That combination places Ganymede among the most intriguing destinations in the solar system. Exactly the kind of place astrobiologists watch the closest. And Ganymede's ocean may be vast. Models suggest it could lie beneath roughly 150 kilometers of solid ice. The ocean itself may extend more than 100 kilometers downward. Earth's deepest ocean trench is only about 11 kilometers deep. Ganymede's hidden ocean may descend nearly 10 times farther, buried beneath crushing ice, possibly layered between different forms of frozen water, pressed by pressures we cannot reproduce easily in any laboratory. And because Ganymede generates its own magnetic field, parts of its surface are partially shielded from Jupiter's brutal radiation environment. That does not make Ganymede comfortable, but it does make it one of the most scientifically interesting places we know of. And we are already on our way. In April of 2023, the European Space Agency launched JUICE, the Jupiter Icy Moons Explorer. JUICE is expected to reach the Jovian system in 2031. After flybys of Europa and Callisto, it is set to enter orbit around Ganymede, making it the first spacecraft in history to orbit a moon of another planet. It will map Ganymede's magnetic environment, probe its underground ocean, and study its icy surface in unprecedented detail. For the first time in history, we may soon find out whether a moon's core can truly continue forming billions of years after its birth. For most of human history, Ganymede was a tiny moving dot near a bright star. Now we know it is an ocean world larger than Mercury, with a magnetic field, with ice older than complex life on Earth, and possibly with an interior still evolving, still settling, still becoming itself. A moon that may not be finished. There is a tendency to think of the solar system as old, stable, done. But discoveries like this remind us how little we truly know. Because even now, billions of years after the planets first took shape, entire worlds may still be changing in the dark. And out there, orbiting the largest planet in our solar system, Ganymede is still becoming something new.